We're live. Oh my goodness. Okay, live from where are we?
CERN.
Voxxed Days CERN.
Yeah.
And we're in Switzerland. This is the third time today. I think people have heard me say this, but we are at Voxxed Days CERN. How's the show so far?
It's good. In fact, it's at the Large Hadron Collider. Like, that's even better. Like,
right.
I mean, screw the talks. Have you been to the tour? You've been to?
Oh yeah, of course.
Yeah.
So they apparently this is rare too. Stefan, or no, it was Mark. So one of the, maybe you, I don't know. Somebody was saying that apparently people work here like 10 years and they don't get a chance to go down there.
Really?
Yeah, because only a certain few people are classified or whatever to let people to give that tour in the first place.
And they got better things.
They've got better things to do. So why would they let them go down? You know?
Wow, I feel special.
And
it was really great down there. I gotta say, like, if you have the chance, it's so impressive. It's like
building.
It's a scientific, like, what's called a measurement device that is like 25 by 25 by 45 meters. That's just
enormous.
Yeah.
It's one slack's worth of space. It's ridiculous. It's so big. And it's humbling too, because you feel like ants, you know, like we're
true.
And then they talk about the beam. It's like a hair's width. Yeah. There's a football field worth of
stuff to measure that and to get it working.
Yeah, like, oh my God, imagine your observability stack was a million times bigger than your actual app, you know?
That's kind of what it is like. That's true, yeah.
Yeah. This is on YouTube, youtube.com/@coffeesoftware. It's there on the top of the screen, hopefully. It's please like and subscribe, because
why not?
Yeah, I mean, there are
since you're here.
Yeah, please. This is on LinkedIn and on twitch.tv/ I think it's Java Josh Long, and it's on my on Twitter X, where I'm excreting right now, and then YouTube. And that's
it's like you go everywhere.
Well, yeah, but I mean, YouTube is way better. Like it's not. I mean, I don't know about Twitch. I'm sure Twitch is just as good. I haven't really explored it. I know nothing. But YouTube is. They haven't embraced crazy things just for.
Which at this point is kind of like a
so rare.
It's a unique selling point. Our USPs, we're not crazy.
Yeah, exactly. So anyway, we're here. I'm joined by you, my friend, my Nicolai Parlog. Can you introduce yourself? Did I butcher the name?
No, that was fine.
Okay.
Right.
Like,
so
wait, fine for like a German or fine for anybody else who doesn't know?
Right. So my last name is actually Romanian. Right. So like, there's no predefined way to say correctly. Like Romanian way is more like Parlog, but nobody generally says that. Even my family doesn't say that. So my family says Parlog.
Okay.
And so in English, I'm Parlog. Like even I say Parlog when I say my name in English. It's kind of weird.
Okay. So good. And you're one of the luminaries over at the big old Oracle ranch?
Absolutely not. The luminaries are the people working on this and creating this stuff, working on OpenJDK, designing the language, fixing all the bugs, improving performance. I'm like more like a mirror. I'm reflecting their light into the community. I'm here to talk about all that stuff because they should be busy fixing it or improving it. I'll be talking about but at Oracle at the Java Platform Group.
Nice. Hey, Alan, I wouldn't worry. So far it looks like it's gonna be great, but I don't know. Just don't worry. You're so far. Seems okay, Okay, so Oracle, are they? I think it's not hyperbolic to say that the number one contributors to the Java.
Yeah,
what we care about as Java, is a lot. I mean, OpenJDK is a community. Obviously, there's a lot of people involved, but a lot of the leadership, a lot of the R&D, a lot of the momentum certainly springs from Oracle, right?
Yeah, no, that's definitely true, but both parts. Like, so it's definitely true that Oracle drives a lot of this, but it's also just as true that there are a lot of other contributors. And working on OpenJDK is nothing people usually do in their part-time. So most of the people working on OpenJDK are actually sponsored by a company that, for most people, that's Oracle, but for other people, it's other companies.
Sure.
And so, so there's a bunch of people working full-time on this, and it's important because this is, as I said, this is not something you can do in part-time. It's too challenging for that, I would argue.
Yeah, no.
I mean, some people do, right? Don't get me wrong, some people do contribute and do minor things, but overall, a lot of the momentum comes from people who have the time and the resources to work on this.
And that's what you want, is a concerted, ongoing effort. Are you out of here forever, or just? Oh yeah. Okay. See you. We're seeing other speakers. So yeah, we want that concentrated effort, and I really appreciate. I don't agree with everything Oracle does, but it's
me neither.
But I will say that the Java stewardship has been second to none, and I have been grateful for them. And I've said it loud and proud, and to anybody who listened, I just couldn't be more grateful for what Oracle has done around the Java language and technology. It is phenomenal, right?
Yeah.
And of course, then they hire the best of the best to help espouse it, to bring the message.
And me, that was so nice of them.
so I'm really glad you're here. So now today, what did you give a talk yesterday or today?
No, it's going to be right after this actually at 3 p.m. I'm going to talk about data-oriented programming in Java 21.
Okay.
/22. Mostly 21, but a little bit 22 maybe.
Let's talk about 21 first, okay?
Yeah.
Because I think that is. And by the way, for those of you who don't know, you're at NIPA FX, I think. On
right, yeah, NIPA
Twitter.
FX, Nicolai Parlog, and then just the FX from the Java FX. That's where I stole it. I'm not creative. That's on me on almost all the platforms I'm active. That's me.
Right.
NIPA FX.
Yeah, and he's got a YouTube channel, or you're on.
I got a YouTube channel,
right?
But most of my YouTube output goes onto the Java channel. So youtube.com/Java. That's a great way to stay up to date with all developments in Java. And I do a bi-weekly.
Oh, is it?
It's bi-weekly, although US English doesn't agree what bi-weekly actually means. So I mean every other week, not 2 times a week. Every other week,
right.
There's a video that's mostly done by me. Some occasionally I got my colleagues to do it if I take a vacation or something crazy like that.
Right.
And it's always about new developments in OpenJDK.
And it's quite good. I've tuned in for a lot of them. And can you so let me see here. It's YouTube. What is it? Java?
Yeah, exactly.
Okay.
That's youtube.com/Java.
They're like a one for the.
So there's actually one that talks about all the stuff that's going to happen in 2024.
Is there a playlist?
Oh yeah, there's a playlist.
I want to send these people.
Go down a bit. Actually, it was on landing page 2, I think.
This one. Yeah,
that's not that one. Should be.
Zip Cafe? No, that's not it.
That's one.
This one, Inside Java Newscast.
View full playlist, I think. That button works too.
Okay, friend. So it's called Inside Java, and
Inside Java Newscast, right? We have other Inside Java stuff. We have Inside.java as a website.
All right.
That's great to observe OpenJDK development as well. We have Inside.java/podcast. Inside.java/newscast. If you go there, you're forwarded to the same playlist.
There,
the
Inside
Cafe by Jose. We have Sips of Java, like whatever length of video, whatever depth of exploration. I was to say explosion. Exploration
wrong word.
Of Java features you're looking for. We got you covered.
And it's great. But you did one because there was you did one right before Java 21 came out. There's a bunch. It did like a whole week or whatever.
Right. So that was something we called Road to 21. That was a series of videos that we made that covers all the changes between 17 and 21.
Right. And so good.
Yeah. So
fantastic.
That's great too, because we put a lot of effort in that, right? Like these regular videos that we do, they all follow like a certain approach, and we've done this quite a while, so we're kind of used to that. But this was the first time that we as a team really said, okay, let's do like a series of videos dedicated to a topic as a team. It's fair who talks about what, and have it look like somewhat similar across the series. And that was a lot of fun, was a lot of effort, and it worked really well too. People really appreciated that, so that's good.
And you did also the day of, you did this like 24-hour.
No, so the super long podcast. The super long live streams. That's what I do for Java's birthday for fun.
Okay.
But that was also I think 8 hours. So that might seem like, to me, that seems almost short-ish for a massive live stream.
Right.
But yeah, it's still long. It's a lot of content.
Road to Java. How do I find the one that you did? That was it pattern matching?
I think that's one. If you click that one.
That one was this one.
Yeah.
This one, friends. You've got to see this one. This one broke my brain.
So you're now a developer advocate.
Yeah, well, I'm a huge fan, right? I love the community of the computer. Anybody who loves the thing I love too, you know. And so this video, I remember you even showed video of you setting up the set. In this one, right?
That's cool. Like, because when you do like a 5 to 10 minute video, you talk to the camera, maybe you walk around a bit, you show some stuff on screen. That's okay.
Right.
But for the 20-minute video, I felt like I wanted to do more. I wanted to like keep it more entertaining and have more changes. And
it was progressive. And you started with code and you just upgraded and all that.
Yeah. So that was a lot of fun. Actually.
Oh, well done. Huge deal. So let's talk about that. Data-oriented programming. That's what you're about to talk about now.
Exactly.
What is it? Why is it?
Okay. Why is it? Lots of things go in there, right? So first we need to cover a few features. So this builds on pattern matching. Pattern matching starts with having a switch that is more expressive than just, switching over a string or an integer or an enum and, then having some case tables. So you can now switch over more complex types. You can say I switch over this arbitrary object. Right. And then I'm saying in case it's this type, in case it's that type, I want to do something different. So what you can do there is you can emulate dynamic dispatch. So dynamic dispatch means you call a method, and then it has to figure out, the runtime usually has to figure out what instance or what class basically to pull that method from. So if you call list.add, or if you call add on a list, I should say.
Right.
If it's a linked list, you get a different method execution than if it's an array list. And so this is dynamic dispatch, figuring out which add code I'm executing.
So it's gets called it like data dispatch.
We'll come to the data part later. At first, this is dynamic dispatch, and dynamic dispatch usually in Java works with inheritance, right? Just the example I just gave, you have a list, exactly, polymorphism. You have a list add method, and then there are different implementations. And that's fine, I don't know, 50, 60, 80, 90% of the time. But occasionally, you're in a situation where you don't want to put a method like that on your interface. We got the visitor pattern for that. Like the whole idea of the visitor pattern is to define operations somewhere, have types elsewhere, and then find a way to get compiler support to make sure that all operations cover all types and all that, which is kind of, the visitor pattern is the right solution as it is, but it's annoying, it's indirect, it's cumbersome.
Yeah.
And hey, nice.
Thank you for that.
Yeah.
He's one of my favorites, for sure.
And so then but what we can do with the switch is the same thing. We can do dynamic dispatch. We can say, okay, switch over this. You could technically say, I'm switching over this list.
Yeah.
And in case it's an array list, I want to call array list.add. And in case it's a linked list, I want to call linked list.add. Don't do that.
Yeah.
But that would work. And don't do that, I mean, because you have polymorphism in place for that. But if you create your own type hierarchy and you don't want to put your method on the interface, that's a way that you can use pattern matching to find the right type and then figure out what to do with that type. Right? So if you have, I don't know, like there's some interface or some super type.
Right.
Let's, for example, let's think about HTML, right? HTML elements. So like it's a certain innumerable number of HTML elements, and say you want to render them, and you don't want to. You could put the render code onto the HTML interface, on the element interface, and into every class. But maybe for some reason you don't want to. So then you would have switch over this element, and then you have a case for each of the, I don't know, gazillion different HTML elements. You would say a case, it's a paragraph. Do this. A case, it's a and that
table
way,
that, list that.
Exactly, and that way you do dispatch. And another cool thing you can do there is if those are records, you can immediately take them apart because you don't actually care about the paragraph. You probably care about its ID or the child elements it contains or the CSS class name. And so you take it apart into its constituents, and then you can process those immediately.
Yeah.
And so
not destructuring, but something like that, right?
I think destructuring is a good term. Like the problem with deconstructing, it sounds a little bit like it has to do, like constructing is creating an object, and deconstructing might sound like garbage collection related, which is not. Destructuring, I think, is a good word. Right, and so that's what pattern matching allows you to do.
Okay.
And data-oriented programming says, in certain situations, for example, in situations where mostly your system can be seen as a stable entity where just data flows through.
Right.
So you don't have like this network of mutable state classes that like hybrid entities, for example, JPA entities that change state, and a request comes in, you change state a bit, and all that stuff. We don't want to do that much anymore, like stateful applications. But in general, if you can see they can also be, for example, let's say you have a batch processing system. They could also see that as something. Data comes in, we munch the data a little bit, and then it goes out to, I don't know, database CSV files.
Yeah.
Right, so in those situations where you're focused on data, the idea behind data-oriented programming is to actually do exactly that, focus on the data, model data as data with records. If you have something, HTML, again, is a great example, it's clearly defined what paragraph is, what a div is.
Right.
Use records to model these.
Yeah.
And then put the operations on them that work with that want to render them or want to do something else. Don't put them onto the data, put them into external systems, meaning like other types, and then have them receive, in this case, an HTML element, do the switch to figure out what they need to do with a specific element, and then operate on that. So treat data as data, treat operations separate from that, really go for immutability. That's an important part. Make sure that your state that your system only represents states that are legal. So don't do this Java bean kind of thing where just create an empty bean, which is like an all, nobody knows what kind of state that is.
Right.
Then call a bunch of setters and hope it eventually works out. Don't. That's a bad idea in general, I would argue.
Yeah.
But specifically with data-oriented programming, the idea is that you only allow legal combinations of values. And records help you a lot with that because they make it very easy to create very precise types. I've got sealed types all the time. Like in this explanation so far.
Yeah.
Sealed types allow you to model alternatives. So say your user has, you have contact information for your user.
Right.
And that could be an email address, could be a phone number. If you're in Germany, it could be a fax number. Only German people get that joke.
Is it still used?
I decline to answer.
Oh no, I mean it's still very common in the United States. I'm just wondering.
I got no idea whether it's still actively used, but you find fax numbers. I think it is, because you still find fax numbers like in the footer of most companies. And like,
right, and it's like you call and it's like, sometimes you even put it in the phone number and it's actually a fax. I'm like, oh, not again.
It happens to me occasionally. You scroll over a website, you see something that looks like a phone number. That's it. I'm going to call them, and then you're like, nope, that was fax. Anyway, so you have this different contact information, and one way to model that with data-oriented programming would be to have a record for each of these types, which is super simple. Record that is email address is basically a wrapper on a string that does all the email address checking, whether it's a proper address, and then you can see the same thing doing for telephone number and for the fax number, and then they all implement the interface, maybe contact information, which is a sealed interface, meaning it only allows these three kinds. It's not an interface like list where everybody just adds new types. It's an interface that says out of the gate, no, only these three types
are permitted.
Permitted subtypes, right?
Okay.
And that gives you a lot of safety. That means that this switching over the type becomes safe, because the switch over the type will not let you get away with just covering 2 out of the 3. You need to cover all 3, and that means if you add a 4th one, you will get a compiler error.
Compilable, so it's exhaustive, right?
Exactly, and then the compiler will point you to the changes you need to make.
Oh, is there? I'm not sure. Are there any plans to introduce something like Kotlin data classes copy for records? What does that mean?
Oh, that's great. Good question. So the issue with records is records are like all the fields are final. Yeah. So if you want to change a field, you can't, which is good. What you want to do usually is you want to create a copy of that, which has all the same fields except for the one.
Right.
Which
you mutated.
Right, exactly. So the way you would write that right now would be that we often sometimes they're called with methods, like setters and getters. They're sometimes called withers, because you often say with title, and you pass the title. And then you get return new, whatever, this dot, you get reference all of this fields, except the title goes in the past title goes in there. And writing those or generating those is terrible. It's more boilerplate. Nobody wants to do that. And so we're probably going to get at some point what's called a with expression, which has been described in a 3-year-old white paper by Brian Getz, where he goes, it's called Java something object model, pattern matching and the Java object model, I think. It's a great article. I can only recommend to read that. Josh is looking at it right now. It's probably going to show up in chat soon. And that's the one. And he describes what he calls with expression. And I really, really hope that now that the pattern matching basics are done, that we're gonna start seeing that progress on that soon. And that specifically means you take a record. I'm gonna try to mirror it for you folks. So you start with a record, you say with, and then comes a code block. And what it does is it takes apart the record into its components, declares a variable for each, and in the code block, you can then reassign some, many, all of those variables.
Right.
Although all would be kind of pointless. But anyway, you can. And then at the end of the block, it uses those variables to call the record constructor. And so you get a copy of the original record with all the changed values. And there are a few cool things about this. One of them is that unlike with the with methods, you only have one instance created, which is probably good for garbage collection. Right. But even better, there's only one point where the constructor checks for invariance, which is important because you have a value and sometimes you have restrictions on what is allowed. Maybe if the last name is non-empty, then the email address might also be non-empty. Right. Which is weird, but let's go with that. Right. So you have one instance where both are empty, and the new instance should have both filled. Okay. But there is no way with individual method calls from one to the other.
You need to check both things at the same time.
Right. So you need to change both things at the same time. Because if you change the one, you fall out of what the constructor would consider legal. Right. And so that's important as well. So you can have one block that changes everything. It goes back to the constructor. There's really no magic. The with expression is something that, if you wanted, you could almost create like a library solution to that. It would not be that elegant, but because records have like the reflective API gives you
you can enumerate the components.
Exactly, you can enumerate the components. You know which constructor to call to put them back together. There's no black magic there. It's just a little bit of basic reflection code that most Java developers will be able to understand easily if you point them to it, and probably even write pretty soon after that. Right. It's straightforward. It's no magic. It gets all the safeties that the constructor call, that accessor calls will give you. It's really cool. I'm really, really hoping to see progress on that this year.
Cool. That is cool.
Yeah.
That's awesome. So I would love to see that too. That's not Java 22, but let's talk about Java 22.
Yes.
Java 22 is what, March?
Yes.
Oh,
And it's already forked.
I know.
So we talked about the Java YouTube channel. Every June and December, we end up having an Inside Java newscast that goes over all the features in the upcoming Java release. And we know that 3 months in advance because the fork happens 3 months in advance. So it's a 6 months release cadence now. And that means that 3 months before each release, the fork happens. And from that moment on, the release branch, you can see like a release branch, the release branch only gets fixes, right?
Mm-hmm.
So no new features. And that also means, by the way, that half the work that happens in any given year
happens
like isn't released during that year. It's released next year.
Right.
And so we already know everything that's in 22. And on final features, the biggest one is the foreign function memory API. It's final now. That's great. Then we have the single underscore, which is kind of cool. And I think that's
that for
unnamed variables and patterns.
Oh, okay. So that's like so other languages kind of had that. And
Yes.
It's not such a big deal, but you have this gray variable name and IntelliJ. It's like, oh, come on, leave me alone.
Yeah.
Like,
so you probably when you write lambdas, that occasionally happens, right? Somebody wants to have like a consumer, like a function. You're like, but I don't care about the input variable.
I'm not going to use it, but I need to define it.
Exactly. So then in the past, what did I do? Like sometimes I gave it like just a single letter variable name, which I usually avoid just to punish it.
Yeah, exactly.
I would call it unused sometimes.
Yeah.
But here's the thing.
Unloved variable name.
Yeah, exactly. The single underscore used to be a legal variable name up until Java 7. It was deprecated in 8 because with lambdas, it turned out that maybe we need this in the future. And it was disallowed in 9. I didn't catch the deprecation in 8. I understood that it was removed in 9. And the reason would be that for those unused variables, we're going to use that later. And my takeaway in Java 9 was like, hey, but that means the two underscores still works. So from that moment on, I used 2 underscores as variable names for like unused. The problem is that 2 underscores is a regular variable name. It's legal, and that means it exists in scope. And if you need a second one, you have to go 3 underscores, which is terrible. But with the single underscore, that is not in scope. It's not a variable that you can refer to, and that means you can have as many single underscores in the same scope as you want. It just means I don't care about this. And
So have you ever seen that movie Air Bud?
No. Wait, is that the one with the dog who learns to play basketball?
Yeah.
Why do I know that? No, I haven't though.
And the reason that whole movie works is there's no rule.
Yeah, exactly. That's why I know it.
That dogs can't play basketball, yes. And it's ridiculous that we have to have that rule because otherwise people exploit it. You are the guy who puts the dog in the game.
Yeah. Right. But that's how I know from that specific aspect of the story pops up in discourse occasionally. Right, and so the single underscore is kind of helpful in those situations where you just don't want to use something. But there's one point where it becomes really important, and that is we talked earlier about switching over a sealed type, and that switch needs to be exhaustive. It needs to cover all subtypes.
I have to, and if I'm using pattern matching, I have to have the variable same thing.
Right.
Switch,
yeah.
Unsealed type foo or switch foo.
Yeah.
Space lowercase foo.
Right, so the issue is this. If you switch over a sealed type and you have to list all the subtypes, then occasionally you're in a situation where you're saying, well, for these 2 types, I want to do X and Y, and the rest is just, I don't want to do anything really.
Yeah, but I have to define them.
Well, you could use a default branch. And here's the thing. The default branch works and does the right thing.
But now you use a compiler exhaustive.
Exactly. Right? That's Josh, 100% right. So the problem is, if you use a default branch and you add a new type to the sealed type, the switch is still exhaustive. The default branch still covers everything. And so the new type silently falls into default, which there's a good chance that this might not actually be correct. And so the right way to switch over sealed type is to avoid default branches. But that means that you have to have every case that does like the defaulty thing separately.
Yeah.
Because you cannot combine in case it's this kind of HTML element or it's that kind of HTML element if you care about the specific variable. But with the underscore, you can. So to wrap this up, you would say switch over the HTML element in case it's a P, in case it's a div, and then you go case, I don't know, did I have span already? Span underscore, comma, table underscore, comma, body underscore, comma. So you can list all the other ones with the underscore and then the arrow, and then you do the default case, which is still more work than writing out default.
Right.
But also HTML element maybe is a bad example because there's like so many of them. And ideally, your sealed type does not have dozens and dozens of subtypes.
Well, but okay, so I can't wait for that. That'll be a quality of life improvement.
What do you mean? Why are you using Future? I'm already programming 22EA all day long. What, you're shipping stuff to production? What kind of developer advocate are you?
I know. It's all in my mind, really. But no, I I tend to. Is there whatever? We'll talk about it later. Okay.
Yeah.
So next thing, I know the answer, but I bet you know the answer, and you're probably going to do a much better job. So we can't use record classes to model our domain classes that need inheritance. Are there any plans in Java to introduce types similar to records that can be extended?
There are no plans. I don't like deep inheritance hierarchies of classes. I would, regardless of records, generally recommend to use interfaces for that. So I think occasionally you have like the abstract superclass that is like a base implementation of something. I think that's fair enough. But the whole way that you get taught how to use inheritance with like cats and dogs and animals and all that, I think that's actually not a good way to use inheritance. So in most, like again, like I gotta say this, I still write a lot of code, but none of that is in a big team shipping to production.
Right.
Some of that ends up in production, but it's like basic just me, and other stuff is like a small open source project with like 4 people. So I cannot speak representative across all software development, Java developer experiences. My experience is deep hierarchies of classes is not a good idea, and it's very avoidable. And so in that sense, we don't need this. If you need deeper hierarchy across a record, use interfaces.
I would say that for 99% of people who are building apps, you're absolutely right. There's probably very little reason to dig into hierarchies, although from a framework perspective, we have lots of slightly nuanced separations of concerns across implementations. It's pretty reasonable to have hierarchies. But again, that's 80% of your app doing that.
Yeah.
Your code should be the last 10%, and the other 10% should just be headroom in case somebody needs to add more of that first 10%.
But also what you're describing is behavior.
Yeah.
And that would not be a record anyway.
No.
Right. So this is more about like states, deep state hierarchies. In the behavior, it's a little bit different. I can see your point, yeah.
But still, I agree with you. For most business apps, in fact, whenever I write production like app code, when I'm consuming the framework or whatever, again, if as long as I don't have to write the framework stuff, which is the whole point of having the framework, as long as I'm not building my own web server and all that stuff, I very rarely have to. And if I do have any kind of polymorphism beyond just one single type, it's an interface.
Yeah.
It'll be an interface plus whatever. And not even there, I loathe the idea of having one implementation of an interface, so I probably don't even have the interface,
Yeah, right. That's also something that if you have control over the code that you're writing, over all the code, like single implementation interfaces are dubious. They're not always bad, but they're like a smell. Like that's important. Also, I think something unrelated to any Java version. When people say something is a code smell or is a red flag, I think it's important to understand that does not mean it needs to be removed. It means you need to stop and think at that point. If you make the decision, no, but that's the right solution, it's fine.
Yeah.
Like not everything that smells has to be thrown away. In Switzerland, cheese, for example.
Yeah. Or I'm going to use that. Yeah.
we all started speaking in yesterday around like big pots of like
fondue,
bubbling liquid cheese. So
okay, whatever. We'll talk about that later. Another off-topic conversation. So that's interesting. All that's good stuff. That's a good question. And personally, I think I would like having a constructor like syntax like records in classes, though, right?
You mean like a simple way to say, like, I have these 3 fields, they're all final. I want a constructor that just assigns to them.
Give me a toString equals and hash code for those constructor parameters, and let me have a regular class otherwise,
But those kind of boilerplate reductions is not something that OpenJDK is looking into very much. Like if you ask Brian Getz about this, he has very low interest in solutions that only reduce boilerplate. The interesting thing about records is that, yes, they reduce boilerplate, but they do more. They have like a meaning. You're saying like this is a transparent carrier for immutable data. It gives you this deconstruction that we mentioned earlier, the with expression, which automatically reconstructs. You get that not because records reduce boilerplate. You get that because records have a semantic attached to them. And so that semantic is the interesting thing that the rest of Java wants to build on further. And so solutions that only reduce boilerplate, and even though I get as a developer that boilerplate is very annoying, usually don't. I think Brian often says, and I can't speak for this specific case, they often don't carry their weight, right? You make the language more complex, you make everything that means learning is more complex, compiler, runtime, you make everything more complex, to save people from writing a few lines that the IDE can generate. Java is always looking for a solution that, might do this as a side effect, but would also give you something else. Cool. And so,
I can respect that. So, okay, back to that was a little digression. It was worth doing, but also back to the thing, because I'm mindful of time here.
Yes.
We mentioned the underscore.
Yes.
Very big feature. And I'm sure that the scores of engineers working on OpenJDK are all consistently focused on that. But I think there's probably something else
Right.
coming
So
in Java 22, something almost as big as the underscore.
right.
You mentioned Project Panama.
Well, yeah, the foreign function memory API. Yeah. So that is final now.
That is final because there was some
It's
doubt.
final. Well, it's final. It's final now in March. It's final in 22.
Yeah. So there was some, like when I talked to Brian in Belgium, it wasn't 100%, but it looked like it was.
It looked like. Yeah. And now we know.
So for those of you who don't know, if you've ever written JNI, rejoice, right? This is because I did a lot of C code. I mean, look at me, I'm balding and.
That explains that.
Yeah. It's I'm actually.
I still have hair. I don't know C. But C++.
Can I? By the way, did you see this?
Was that a hair joke?
Yes, actually, no, not that one. This one.
Oh yeah.
Can I highlight that or no?
Yeah, of course.
Oh yeah.
I'm always here for jokes about hair.
So good.
Right. So again, the reason why I still have any, I don't know C, I don't know C++. I'm happier for it.
Yeah, and you should be. And in order to use JNI, hey, we already have tuples. That's called a record, right? Nominal tuples. They're records with a name.
Yeah. So if you need a tuple, if you feel like I need to put these two things together, just create a record. It's a one-liner. Just say record, string name, comma, path, file, whatever. You have your record, you have your tuple now, but it has a good name. It's type safe, and you also have accessors that make sense. You call it name and don't call first, and it's a one-liner.
The question was, do you plan to add tuples as a native type to Java? E.g. pair AB and triplet ABC, and the answer is no, and that's straight from Brian's mouth and all that. And I like that because the syntax is you can do it in a method. You can actually create a record in a method.
Yeah,
it doesn't have to be public record or whatever.
And that's not new to methods, by the way. You can create classes in a method.
Yeah, for years.
Like, I didn't know that, and I think it's good that we don't. So don't do this. A record, I think a local record, can be okay.
Yeah.
Specifically, sometimes you have like a stream pipeline. You know that you map, and in a map you kind of lose like the original object, but sometimes you need the original object to keep around, and so you can create a record that will contain all the exact information that you need. You put that into your little method, and that works. And if you need to pass it outside of that method, you can just put the definition of the record outside the method.
One level higher. It could be inside the class too.
Yeah.
Or public top level. Okay. So anyway, Project Panama.
Yes.
To me.
No JNI.
Yeah. Oh God. So and also no JNA, which I loved. JNA was dope, but it never got like blessed as part of the thing. JNI, for those of you who don't know, have you ever wondered what that native keyword is in Java? You type in there's some methods in the JDK that are like native. I think the hash code for object is public native int hash code, right? And that native is basically saying, hey Java, before you run this code, look on the link path, not the class path. Look on the operating system link path for this code and find a DLL or .dylib or .so for Linux or .dylib for Mac or DLL for Windows. Find a library that's on the link path and look for a C or C++ header that has a function that is named in tandem with the package and the class and the method here. So you have to export a public function in a header file in C that lines up with underscores instead of dots and all that, with the native function definition. And if you refactor that native function, make sure you recompile, change it, and then recompile your C code. And then if you want to work with data, if you accept a method in that native function, you need to now work with it in terms of the C library in that native code. And you can actually get like an int in Java. You pass in an int, it becomes a JInt in C++, right? And using this JDK JNI library. And so you can't use native code from Java unless you know how to write native code. Yeah. And this is a real pain in the butt. I know how to write native code, but look at me. I'm only 27. Look at me. I'm dying here. I'm lying. I'm 40 this month. But yeah, it just takes a toll on one's health and safety. Imagine how much smarter I could be if I hadn't gone down that rabbit hole for a decade. So all I'm trying to say is every other language has this right. You can just invoke native types from the code. You don't have to write native code to use the native code.
Yeah.
You don't have to write native code glue code. So and there's two different problems to this. One is like if I write native code, it's very fast, but of course, marshaling back and forth data across the native to Java boundary and then managing memory and pinning it down becomes an absolute Herculean effort. On the other hand, if I do things dynamically, if I use dynamic dispatch to sort of look up a library and enumerated types, which a lot of operating systems will support, that it's very slow. That's reflective C basically, and it's very hard to do. And you have to compile your libraries in a certain way. So all of this isn't great, but I'd still prefer. I want some way to tell Java, hey, here's a function, here's the types it has, here's the input parameters and output, and also here's the memory it's expecting. It's expecting a pointer versus a reference versus whatever, and I want that memory to stay constant through the life of my invocation. And all that stuff is sort of anathema to what Java does. Java has a garbage collector. Exactly. You can't control lifetimes, and you certainly can't think about, like, there's no mapping. There was no mapping for things like a struct, right? Yeah. In C, right? How do you take that and convert it into a Java thing? It just becomes painful. So now Project Panama, which is like I think it's the most previewed JEP ever, right? Like,
it took a while.
7 years, 6-7 different revisions now, or whatever.
Right. So they started with the foreign memory API and incubation, I think, and then that's our preview, and then we folded in. I'm pretty sure. I'm not sure it's that order or the other way around. The foreign function. So foreign memory is managing data off heap. And then foreign function is calling C code, and that goes hand in hand for the reason Josh just explained. You don't need to use, if you use foreign memory, for example, you don't need to also use foreign functions. But if you use foreign functions, you very often have to, the stuff you pass usually lives off heap, and the stuff you get back usually lives off heap. So that's why they belong together. There's like a lot of overlap between those, and it's good if the APIs play well with one another. And that was previewed for quite a while, then merged into one. And that's interesting because sometimes people feel like the Java versions they get long-term support, they get some kind of special treatment, which is categorically false. Like within OpenJDK, every major release is treated the same way. And some people say like, for a major version, you're gonna rush to finish all the previews, which foreign function memory API proves wrong, because it was like on the cusp of being done in 21, but the decision was made. We want to make sure, we want to give it one more round of preview. We want to make sure that the last changes we made actually landed well. And so it's final now in 22. And so everybody out there who deals with native code can go ahead and enjoy that. But also everybody like me who doesn't also gets benefits, the indirect benefits, right?
So the library, native code.
Yeah, maybe. But even if I don't, like the library that I'm using that depends on native code, maybe now spend less time on following the development of the underlying C library. So, for example, one of the reasons why Java is one of the not few reasons why Java is not that great in machine learning and AI is that most of the core of that is written in C and C++, and it's tougher for Java-based libraries to follow that closely, the development, if the underlying library develops a lot, because it's a lot of effort to keep the glue code and everything going. And FFM API will simplify that a lot. And that situation that your favorite project that deals with native code can spend less time on the dealing with native code and more time on whatever else they build around it.
Not to mention less time, like if you're not using JNI, you don't have to write native code. It's one thing to integrate with native code, to call it in a useful way, which is what we're talking about here.
Yeah.
But if I have to write my own headers, my own implementations of those headers in C and keep a up-to-date C tool chain around, my goodness, that stuff changes all the time too.
And make it easier for noobs like me to experiment with that and be like, maybe I can give it a try now. Yeah,
and
it's good.
It'll probably never happen. But my dream is one day maybe we have like a Spring module for some, like what if we have like a FFM template that uses libav codec or something.
Okay.
And we abstracted that from people using Project Panama. It'll never happen. But there are possibilities here now because libav codec is amazing. Like YouTube is built on that, right? Like Spotify, everything is using libav codec somewhere.
Now I get it. Yeah.
It's a library behind FFmpeg.
Yeah.
FFmpeg is a command line tool that talks to that DLL.
Yeah.
Now we could talk to it from Java. Suddenly we have what is that library for? We have the libbluetooth, and we also have the JavaFX media player stuff.
And
there's also the image IO stuff. But come on, FFmpeg is a mile ahead of everything we've got.
Yeah, so it opens up easier interaction with native code, operating system specific code, and also as I said earlier, it's also easier to follow along, right? Because that's a problem. Like if you sit down, you have this problem, you really want to solve it, you might be willing to invest that time, but are you willing to maintain that solution for the next years? And then that's often why then these projects, even like maintenance or just stay on older versions, because that constant maintenance work is just higher than it technically. Well, it needed to be that high. Oh, sorry, it was that high.
Right.
The work needed to be done in the past, and hopefully the overhead is lower. So again, people can spend more time on other things.
I'm mindful of time, but
my talk starts in 17 minutes. So I got a little bit.
So the thought experiment I like to engage in, perhaps errantly, is what would it have taken to persuade the developers in the room in 2011 or whatever it was, to use Java instead of Go for building Kubernetes. Okay. now I think Go routines, you got virtual threads, right? Project Panama, there's no reason I couldn't interrupt with the kernel and C groups and the things that the atoms that build up Docker and all that stuff and Go and C. That is now available to me in Project Panama, right? And then of course we've got Project Layden. In the meantime, for the moment, you've also got things like coordinated restore checkpoint, and maybe that other thing with the G.
Just native image guard.
You can GalVM. I mean, those things give me the small form factor, lightning fast performance. I would never need Go today if I were building a Kubernetes from today.
Yeah.
We're not going to build Kubernetes in Java, okay? Just don't stop it. But I'm just saying, if we had been there in the room 15 years ago, who knows? Maybe the world would be different today if they had all these things here. It's amazing. It's an amazing time to be a Java developer.
Yeah. So there's a lot of lenses through which you can see these large projects. One lens is you compare Java to other languages, and syntax aside, other languages, like for example, Go routines in Go was like a clear advantage. Go ahead over Java that went way beyond just like I like the syntax worse or better. And Loom fixed that.
Yeah.
And made it, if nothing else, they made it close enough so that distinction doesn't matter anymore. And that's important. Right? So you can see many of these projects through this lens of, compared to some other language that is better in that way, Java lags behind a bit. And if we fix this, it's going to be even. And the cool thing is, if you pick the strongest language in each of these fields, and Java has Java wants to compete with the strongest language in each field, that means even if it's just like second place by a small margin in every field, that still means that it's
in the game.
But also like the best language in each field is not always the same language, right? If it has like if it has virtual threads like Go routines like Go, but it still has like the Stellar's tool support and the reflection support, the reflective approaches and observability approach that Java has, but we'll also have like the small startup, the short startup time. It just it doesn't need to be the best in all regions. It just needs to be really, really good enough that all the other benefits that Java has, and the fact that it is so good across the board beats other stuff. And I think that's really a goal, to keep Java being a universal programming language that can compete. Or at least doesn't have to hype in any other language in any other space.
Nope. And I'll go one further. I'll do one better on the virtual threads thing. I think Go was the only language to have gotten this right before, because all the async await stuff kind of like, it's a whole other kettle of fish. It never worked for me. Yeah. Go was the only one that got it right. But even there, they had the benefit of starting from zero and doing it only the one way. What Java did is even more impressive. Yeah,
Lou is crazy. Like being able to retrofit it into an existing system. That's
Java's got the best implementation, bar none. If you want to do this, there's no better way than Java. And if okay, that's part one. Last question, I guess here. Petro, in for the win. Any idea when we can expect, speaking of virtual threads?
Yeah, structured concurrency and scope values are still in preview in 22. My personal prediction has been that this will be final in the year 2024. But as I mentioned earlier, like second half of this year's work doesn't show up before 2025. So I think we can definitely say, not definitely. I can definitely predict, and I might be wrong, and that's only on me. Don't sue Oracle. Don't sue me either. Just sue nobody. Just don't sue. Yeah. Is that I'm very, very confident that Java 23 or Java 24 will see finalized structured concurrency and scope values. Talk about 22 quickly, because we just like other previews, structured concurrency and scope values. We have string templates in preview. We also made progress on making Java easier for beginners, but we're going to carve out that topic for another time. G1 has region pinning now, which is good, I guess.
What?
G1 has region pinning now.
Oh, cool.
Which is a thing, apparently. That's finally in 22. And there's more previews. Probably I'm forgetting some. Java 22 is big on previews again. There was an accident, but it was like a kind of lucky accident. 21 happened to finalize a bunch of stuff that wasn't pretty long, and then 22 basically restarts a bit of the pipeline. So that's why they're only like underscore and FFM API that are really like very interesting surface level features that are now being final.
The FFM, but again, don't sleep on that FFM API. It's been like almost
friends
10 years.
Don't let friends write native code.
No, yeah, and it's been like it's got to at least be 5 years, but it's probably 10 years since I've been hearing about native Project Panama, whatever. I mean, it's just forever, and it's here. It's finally here.
Yeah.
Virtual threads has been around. They've been having that's a on again, off again discussion for the last 30 years almost, but that's here last year.
Yeah.
Now Project Panama, oh my goodness.
Now Panama can go back to sleeping on the Vector API. In case you're waiting for the Vector API, it's in a weird state. It's basically done. It's basically production ready. It's all good, but it might change in the future. It wants to change when Valhalla comes along, and it's waiting for that.
What's Valhalla now?
Project Valhalla, value types, generic specialization. That's all the time we have. But unfortunately, so that means the Vector API is in this limbo state where it is done by all intents and purposes, except the API might change on the surface level. And so if you now start piling like 2 years worth of code on it, you might have to rewrite all of that. Nobody wants that, which is why it's kept in incubation. But if you're willing to do that, if you're willing to rewrite every line of code that touches the Vector API, you can use it. It's stable. It's good. It does its thing. If you've caught up on the 1 billion row challenge by Gunnar Molling, some of the highest performing solutions do use the Vector API.
Yeah,
and it's good stuff.
He was on the show yesterday on this very channel. So if you
really, good channel,
I wanted you to join. I wanted you to join the show yesterday too, but it was, you're a busy guy. But yeah, he was on the show yesterday, and it was good. We talked about just that.
Okay, I got to run.
Thanks, everybody.
It was fun. Bye.
Bye. Thanks. By the way, I appreciate you.
Sure.
Good luck on your